Okay, watch and listen carefully here, guys. So we have an inclined plane, okay, in our first question here. And it's my favorite angle, 30 degrees. And the object is being lowered down the ramp, which means it's actually going down the ramp, but someone's pulling up on it to reduce the rate at which it slides down the ramp. Everybody follow me there? Okay, so we know that the acceleration of the box is 1.3 meters per second squared. Okay, we know that the force of friction is 25 newtons, right? And we know that it's acting up because the question tells us the box is going down the ramp. Okay, we are looking for this force here, the tension in the rope. Okay, the whole reason that the box is going down the ramp is because F parallel is pulling it. Right? These are the forces that are going to be involved in calculating the net force for this question. Okay, so first thing we got to do, okay, is we've got to find what our F parallel is. Okay, so we got a 40 kilogram box here, so we can figure out what our force of gravity is, and then get our F parallel, okay, which would be this side. We don't need the normal force in this question because they told us what friction was, so we don't have to calculate it. Okay, so give them a mark if they've got free body diagram, looks something like that. It's kind of their givens. Okay, so we got a 40 kilogram box times 9.81. So there's our weight, okay, or the force of gravity acting down the ramp. Now I want to get F parallel, which is the opposite side. So I'm going to multiply that by the sine of 30, which is 0.5, okay, but we'll put it in anyway. So our F parallel is 196.2 newtons. Right? So that's the amount of force going down the ramp. Okay, I can calculate my net force right now by going m times a, because they told me the acceleration and I know the mass. All right, so that'll be my next step here, 40 kilograms times 1.3 meters per second squared. So they'll get a mark for that step as well. Okay, so our net force is 52 newtons down the ramp. Okay, so I'm going to make down the ramp negative. Everybody all right with that so far? Okay. Next step here, we got to use the sum of all forces to calculate the force that we don't know. Okay, tension plus F parallel plus the force of friction, vector sum of all forces equals F net. So I'm looking for T, so I'm going to subtract these other things over. So I'll have that T equals F net minus F parallel minus the force of friction. Give them a mark if they've got a sum of all forces calculation in there. Okay, so we're up to 3 marks there. Okay, so we've got negative 52 minus negative 196.2 minus the force of friction, which is 25. Okay, so when we do this calculation here, oh, sorry, I meant for you to get a mark for calculating F parallel. Sorry. So if they have F parallel, calculate to get a mark for that. All right, so we are going to have negative 52 minus negative 196.2 minus 25. All right, so our force, our tensional force is 119.2 newtons, but we only have 2 significant figures in this question. So our tension is going to be 1.2 times 10 to the 2 newtons up the ramp. Okay, 5th mark. Okay, questions on that one? Okay, that was my inclined plane question 2 years ago on the unit exam. So you know what kind of ones I might ask. All right, so in this one here, I'm trying to push a heavy box across a level floor. All right, so the floor is level. That's an important thing to know. Okay, we don't know how heavy the box is. That's what we're looking for. Okay, I'm using a force of 3,500 newtons because I'm huge. 3,500 newtons is a lot. Okay, all right, 3,500 newtons. but I'm unable to move it. I know that the coefficient of friction is 0.937. Okay, I'm looking for the mass of the box. Give them a mark for that. Okay, givens there. What's the most important thing I need to realize in order to solve this question? The net force is 0. Okay, if I don't make that realization, there's no way for me to even start this question. All right, the net force is 0 in this question. That means that the force of friction is 3,500 newtons. Okay, so if they have somewhere in there that the force of friction is 3,500 newtons, or they have somewhere in there that F net equals 0, something like that realization, okay, that's intuitive, but it's worth a mark. Okay. All right, now that I know that friction is 3,500 newtons, I can now solve for the mass of the box using this formula. But how am I going to alter it in order to get mass in there? The floor is level. So normal force is equal to, right, it's equal to the force of gravity. That's the other thing we have to realize in order to solve this, okay, is that normal force and gravity are equal in this situation. The box isn't moving. So, in other words, I can take Fn out of here and say that the force of friction equals mu times the normal force, or times gravity in this case, because they're equal. And now I can solve for m. So give them a mark if they got to that point there. Okay, that's 3, and this one's only out of 4. So I got to solve for m. So that's going to be force of friction divided by mu g, okay, equals m. So that'll be 3,500 divided by 0.937 times 9.81. 3,500. Okay, so the mass of the box, and no wonder I couldn't move it, was 380 kilograms. Okay, and we only have, do we have 3 sig figs in this one? We have 3 significant figures in here. So 380 kilograms. Fourth and final mark on that one. What does it round up? I didn't look. 381, you're absolutely right. It does round up, 381. Okay, good catch. All right, give them a mark out of 9. Let them see it and then put it on the desk right here, please.